Okay, good morning. I'm going to try my very best to make this kind of a quick recording because there's not tons of new stuff today. It's really more practicing and learning a couple new vocabulary words, as you might see in the title, standard form and factored form, and really just applying it to what we already know. And in my live session, many of you attended on Tuesday. That was awesome to see you guys, or at least your screens there. This was better than the real-world applications in Desmos. So a lot of you said that you're comfortable with multiplying out stuff that looked like this, and we're going to do a lot of that today. So we're going to show that this is equivalent to this. And that's your little warm-up for today. Show that those two are equivalent either by drawing a diagram or by distributing. All right, so take a minute, and I'll show you both of those in just one moment. So I made this area diagram look a little bit different. Doesn't have to. You can just keep it as your normal ones. So if you want to ignore my colors, go for it. But I made it so that the whole blue square was x. And really what's going on here is you have the big x squared. The blue thing is the x squared box. But then you're removing one from each side. So there's a minus x here. This whole bottom rectangle is a minus x. And then this whole bottom rectangle is another minus x. So it's negative 1 by x. And then this bottom right one is a plus 1 because you've got two minus 1s. And realistically, it's plus 1 because when we subtract this red square and this red square, we've really subtracted this bottom right square twice. So now we have to add it back in. But really, if you just keep them all as blue and you just say that, well, my side length is negative 1, and you just kind of pretend that that's allowed, it'll actually work just fine for you. All right. And these are not the same blues, so I'm just going to stick with trying to make them all different blues. All right, so there's that one. And you get x squared minus x plus 1, or x squared negative minus 2x plus 1. And that's what we're supposed to get up here. Awesome. And then if I just distribute, like I know we know how to do, and you guys have been doing super awesome with your exit slips, if I just distribute, I would get x times x. So distribute that x to the x and get x squared. Distribute x to the negative 1 and get negative 1x. Distribute the negative 1 to the x and get negative 1x. And then distribute negative 1 to the negative 1. Now just get a plus 1. Or x squared minus 2x plus 1. Because negative 1x minus 1x gets me negative 2x. All right. So hopefully we're getting pretty comfortable with that. And let's just move on. We're going to practice these two. Again, whichever method you feel more comfortable with. Draw an area diagram, pretty hard on a computer, but paper and pencil is always fine too. Either draw an area diagram or distribute. Again, I'll just pause it, leave it for you to work out on your own, see if you have any questions. All right. 3 answers here are in red. The first step for this one would be, let me see if I can just write it out real quick, x squared plus x minus 1, and then that would simplify to x squared minus 1. Again, that middle term seems to cancel out. Very interesting. You might notice the situations where that happens. You might have noticed a pattern of what the equations look like when that happens, if you remember the ones from last lesson where it happened. We'll talk about that more later, though. Okay. So then, next one, x minus 2 times x plus 3. The original after distributed form is this. And it turns into this when you add 3x and the negative 2x. The x terms will simplify. And then right here, if I do x minus 2 squared, I do x minus 2 times x minus 2. Remember, it's not just x squared minus 4. You have to actually say x minus 2 times x minus 2. And then distribute from there. So x squared, x minus 2, x times negative 2, negative 2x, negative 2 times x, negative 2x again, and then negative 2 times negative 2 is a positive 4. So I get x squared minus 4x plus 4. So hopefully that's going pretty well for you. Shoot me an email with questions, and then we can move on to the next part of the lesson. So really we're going to learn about the 2 names of the ways we can see equations written. And we'll see them written mainly in a couple different forms. Our word problems didn't always look like this, but mainly when we're dealing with them, it's easier when they're in one of these 2 forms. And those 2 forms are standard form and factored form. So the quadratic expression, uh, x squared plus 4x plus 3, is written in standard form. All right, and so here's some other quadratic expressions. The ones on the left are written in standard form, and the ones on the right are not. So take a minute and look at the ones on the left. See what they have in common. And look at the ones on the right. The ones on the right are not in standard form. So think about what are the characteristics of the ones in standard form, and maybe what are the characteristics of the ones that are not in standard form. And I'll pause it, give you some time to think about that, and I'll compile a list while you are paused. The main difference here is that the ones written in standard form do not have parentheses. Hopefully that was visually apparent. Everything not in standard form seems to have parentheses involved. And standard form is exactly that. Everything is just something subtracted by something, something added to something else. There's just addition, there's just subtraction. The x terms have numbers before them, that's okay, but there's no like parentheses anywhere. And you're going to learn a lot more about standard form and dealing with stuff in standard form later, and we're going to learn about the other form as well. All right, so standard form, no parentheses, we're just adding and subtracting. Sometimes in standard form, I will say, usually, I'm writing as an exponent now, hold on. The x squared term is first, and the constant, no x, is last. That is what I typically default to, because that's what I grew up with. I don't really think, we'll see if they define that more later, but really the x squared term often comes first, and the constant term comes last. It goes in order, so like highest exponent, medium exponent, no exponent last. All right, that's what usually happens. All right, and then these ones are not in standard form, but some of them are in another special form. So we're going to look at x plus 1 times x minus 1, and then x plus 8 and negative x plus 5, and then 2x plus 3 quantity times x. And those ones in the right column, they're all quadratic expressions, and they're written in what's called factored form. And it's called factored form because the entire expression is just a series of multiplied quantities. And notice it's okay that inside the quantities, there is addition and subtraction. So like that one is really just the product of x plus 1 and x minus 1. It's a multiplication problem. And it might look a lot less satisfying. You might be like, well, can I just multiply it out? And like, yeah, you can. But there's actually some really special reasons why we do not multiply them out in some situations, which we'll learn about more later. But just to get in the vocabulary to you now, these three are all in factored form because it's just two quantities multiplied together. It's x plus 1 times x minus 1. It's x plus 8 times negative x plus 5. And it's 2x plus 3 times x. All right, so that's our factored form. Two quantities multiplied together. And that is basically our new learning for today. I probably could have put another lesson in here and combined it, but I think I'm going to try to give you more reasonably paced stuff, and because this is a great lesson to review our multiplication of quantities and our distributing. So that's really our lesson for today, learning about what standard form means. Standard form is basically, it's the sum of a multiple of x squared and a linear expression. So yeah, we have our x squared, and then we have our mx plus b. All right, and down here, the general form, we are getting general form. So standard form is ax squared plus bx plus c. We call c the constant, a is the term before the x squared, it's the coefficient of the x squared term, and b is the coefficient of the linear term. They couldn't have made that more confusing because usually b is the y-intercept, but whatever. So now b is the coefficient of the x term. B is where slope would be. We won't talk about that though, that's fine. and it has two different terms. So really this is standard form, and if I put it in factored form, it would be this. We don't know how to go backwards yet, we'll get there later, but really this is factored form, and this up here is our standard form. Yeah, so when it's written as a product of two factors where each one is linear, this is called factored form. So if it's written as a product of two factors where it's like x plus something and x plus something else, or x and 2x plus 1, it's factored form. All right, and then let's see, anything else interesting down here? You can expand it by writing it in, you can expand it by distributing to write factored in standard form, and we do not have to go backwards. Here's just another example of how to go from factored form to standard form. So if you're stuck on that at all, feel free to use this note to help you. Other than that, you got your Google form. Best of luck to you. Enjoy your day.